And this workshop is near the one chain to abstract them all. And we'll talk about why it is the one chain to abstract them all. So today we're just going to go over like what bounties we have and give an overview of the tech stack. Most of you here are probably familiar with like EVM, so I wanted to give a bit of an overview how this actually like differs from EVM and give an overview of the whole like near stack rather than diving into just like one example. So it'll be more theoretical rather than me sitting here programming, right? And we'll talk about like how you can access the documentation, how you can get support from most DevRels here, and I'll give you some ideas if you don't know what you're hacking yet. So in general, like why should you build on Near? Well, it's fast. We have like 2-3 second finality with like 1 second block generation time. And it's sharded by design, so it's horizontally scalable. Theoretically, it's infinitely scalable, but we'll see if that is actually the case in the future. And it's very cheap. We don't have any roll-ups. We don't need any roll-ups because an average transaction is like less than a cent and a couple cents for storage. And it's pretty dev-friendly, which makes it pretty user-friendly in the end of the day, because we have things like named accounts, a unique access key system, built-in account abstraction, things like meta transactions, and we have the ability to sign transactions on other chains with chain signatures, which we will look at. So first things first, the account model. We have two types of accounts, two types of account names. The first one is your standard 64 characters of mumbo jumbo that you can never remember and you just have like in your clipboard. But we also have named accounts. I'm PyVortex.near, and this is like a really nice way to just remember accounts and to organize your application. So for example, you can have an app which is like app.near, and then you could have the token fall under the same name, so like token.app.near. And it's really easy to deploy like new accounts, we call them sub-accounts, from within a contract. So for example, you can have this like app.near, and then you can create accounts for your users. So I might create like pyvortex.app.near, and within that account, I can like airdrop you some tokens when your account is created. Or, because as you can see, accounts are smart contracts, they're the same thing. On Near, we don't have like external owned account or whatever you call it, and like contract accounts. We just have accounts and they're contracts and they're the same thing. So basically you can deploy accounts and deploy contracts to them from another contract, which we call like factory contracts, right? And my favorite thing about Near is its access key model, and this is really undervalued and not utilized so much. So if you can build something with access keys at this hackathon, I would applaud you because I would love to see it. So we have our standard like full access key pair. This is what you think about in Ethereum. You just have your one key and your seed phrase, and this gives you full access over your account, send transactions, view your balance. Well, you don't need a key to view your balance, but do whatever with your account. And on Near, you can like swap in and out your keys. So if you were to say expose your private key or seed phrase, if I just put it up on the screen here, if I was quick enough, I could rotate my key. So if you were to use it, it wouldn't do anything anymore. And that's like the power of Near's account model. And also, even more interestingly, we have limited access keys, which don't give you full access over your account. And they allow you to do certain things and sign certain methods on certain contracts. And with these keys, you're actually supposed to give them to people or give them to applications, which seems a bit of a weird concept, but let's look at what that means. here's sort of the meme, like the future of gaming on Web3. You want to shoot a bullet? Well, you got to sign in your wallet, right? Well, that's not the case with NEAR. The idea is that you give this application your access key, and it will sign these transactions for you. So you don't have to go into your MetaMask and click sign to shoot a bullet. It will just do it. And another cool use case is, for example, say I had an account that was for social media, and I had like an intern. I don't want to let that intern delete my social media account or change like my bio or something, but I want them to make posts and like other posts. So I can give them a function called access key to just post and not edit any of that other stuff. And I don't put my funds at risk to that intern to do stuff. And we said that limited access keys can only sign transactions for certain methods on certain contracts, but contracts can do everything that an account can do. So you can have a method that, say, creates another account or adds a key or sends funds. So I could have a key that allows one to create an account and send fungible tokens to that account. So you can really do a lot with these access keys. And next up, meta transactions. You may have heard this before, but the idea is that you pay for your user's gas for your application. And with NEAR, it's not some like third-party service. We actually have this built in at the protocol level. So if Anna or Anna.near wants to send a transaction, what they do is they sign it client side, and then they wrap it in like a meta transaction and send that. No, they don't do that yet. They send it to a relayer first, who wraps it in a meta transaction, who then signs this larger transaction that the inner transaction is wrapped in, and then they relay it to the network, and the network says, hey, this is a meta transaction, let's remove that bigger transaction and look at what's inside. And then it executes that transaction as if it was sent by the user, but in the middle of that, the relayer paid for their gas and paid for the deposit. So this is a really good way to like onboard people to your application, because with Web3, you've got to go through like onboarding, you've got to on-ramp, you've got to sign up for KYC for Coinbase or whatever, and move some funds, move like Ethereum onto your account to actually be able to interact and pay for gas. But what you could do is just like airdrop someone an account and just have them sign transactions without funds. Or you can have it so they just interact with stables and you don't have to touch like the NEAR token at all. And I did say my favorite thing was access key model, but chain signatures is probably my second favorite. It's really quite cool. So this is the idea that NEAR accounts can control accounts on like nearly every other chain. Basically, a NEAR account is not just a NEAR account anymore, it's a multi-chain account. And basically you derive new accounts, like foreign accounts I like to call them, from your NEAR account, and this comes from your account name and like a derivation path you provide it. So this could be like, on like a hardware wallet or just any other wallet, you have this like derivation path where it's like 0 / some numbers. That's basically the idea. So you can have like thousands of different accounts, I think millions of different accounts, just derived from your NEAR account. And you can sign transactions for these derived accounts on these different blockchains. So I, who owns a NEAR account, can sign transactions for Ethereum via the multi-party computation network, which is pretty damn cool, to be honest. So how does this actually work? Let's work through the flow. Anna, again, she's back. She wants to sign a transaction on Ethereum. So she asked the MPC contract to sign this transaction for her. And when that happens, the MPC contract makes a request to the MPC service, which is built up of like, I think it's like 8 nodes at the moment. And that signs the transaction, returns that signature back to the MPC contract, which then in turn sends it back to Anna. And then Anna, or a relayer, captures that transaction and the signature, puts them together, and sends it to the target blockchain. And that can be whatever you want it to be, like Bitcoin or Polygon or mainnet Ethereum. Oh, I have some QR codes here, by the way, and these just sort of link to the relevant sections of the documentation if you want to peep them out. And yeah, so the steps to this, there's 5 main steps. The first is to derive the address. So you pass the MPC contract the path that you want to use to derive the address. So you might have some like path standards to derive them, so everyone's using like the same account. So you derive that address, you then create the transaction, you say, what action do I want to do? I want to send Ethereum from this account to that account, or I want to call a transaction, call a contract on Ethereum. And then you take that transaction, create a payload from that transaction, and request a signature from the MPC network. And like I said, you get that back, reconstruct the signature, and then the last step is relaying the transaction. Video. Will this video load? This is just yeah, so this is how it works in like a front-end app. So you log in with your Near account. This is the derivation path I'm putting in now. We'll just call it Ethereum. It gives you an address. We'll send some funds to that address from like a MetaMask wallet. This is on Sepolia, by the way. Wait for that to go through. And you can see we're sending it to an address here. We can see we have balance now as we would expect. And we're going to send 0.01 ETH to that account. So we request the signature. We got the signature, and then we relay that, and we should, yeah, there. We get a transaction link for that, which we can check was successful. And that was all from just like having a Near account and not having like a private key for an Ethereum account. I don't want to play that again. So we talked about like 3 things here, right? The account model, meta transactions, and chain signatures. And if we bring these concepts together, we end up with chain abstraction, which is the idea of interacting with any blockchain, interacting with Web3 as a whole, and not knowing or really caring from a user's perspective of what actual chain you're using. So the idea is to benefit the user experience through chain abstraction. And some things to think about is that, remember that smart contracts are accounts, and accounts are smart contracts. So contracts themselves can actually call the MPC network, which allows contracts to control accounts on other chains. So this allows you to embed logic, like smart contract logic, onto Near for other chains. So all chains can now inherit the good things about Near. Maybe you like Ethereum, fine, go ahead, I don't care. Build on Ethereum, I love Ethereum too. But why not also have Near's account model? So I can now turn an Ethereum account, I can now call that PyVortex.Near because it's derived from my account. And I can also inherit Near's finality. So, I don't know, how long does a Bitcoin transaction take to like be confirmed? A while. But if I make that swap by swapping like a Near account for a smart contract, I can now inherit Near's finality of 3 seconds and inherit its gas price of like a couple cents or less than a cent. So what can you actually do with this? Like, here's some ideas. So the one you think of first, and maybe the most obvious, but also like the coolest, is swapping assets from different chains. So I could swap Bitcoin, like native Bitcoin, for say USDC on Arbitrum. with near's finality and gas price. Or you can create link drops on foreign chains. So I airdrop you an account with Ethereum, an ordinal, and some more USDC on Arbitrum. You can also, one thing I would love to see implemented at this hackathon is, oh no, you can't see it. Well, we can show my screen. I'll just stand like this for the whole thing, if you can see it. This one here, cheap multi-sigs. I would love to see someone implement this. The idea is that you can deploy a multi-sig on Ethereum by just like deploying the logic on near. Is it back? Lovely. So you deploy the logic for a multi-sig. Oh no. We'll give up with the screen. You can deploy a multi-sig on near, but have it act on Ethereum mainnet, which allows you to deploy a multi-sig for like cents. And you can have like an account with social recovery via implementing it on near. I can see it's back. So yeah, this is something I'd love to see. You can also do things like DeFi on Bitcoin, or like I don't think this is a word, but integrationless services that are available everywhere. So you could have some like ZK proof verified on near where it's cheap, and then broadcast it to whatever chain you want, or things like prize feeds. And you may have heard that near is the AI chain. So we've gone back to our AI roots. I don't know if you know Ilya. I don't know how to pronounce his last name. Ilya Pelushkin. Well, he is like GigaBrain, Google AI, who founded near, co-founded near. Well, we're going back to his AI roots and building an ecosystem of AI through like data and like AI agents. So how does AI actually come into near? Well, it's less in terms of infrastructure and more about building an ecosystem of where AI can live its best life. So if you're building an AI agent, why not build it on near? Because you're not just building it on near, you're building it for every chain, because this AI agent can now transact on Ethereum, on Cosmos, on Arbitrum, on Polygon, just because you built it on near. And things like the named account model really brings like life to these agents, so you can give it better identity and have this AI agent that has its own name, its own account to transact across these multiple chains. And try to think like, how can a smart contract make decisions via AI? So on near, contracts can yield and resume. So what that means is you can have a contract that calls like an AI model and waits for its response, and then executes on the contract and like changes its state based upon that result from the model. And one thing we're quite bullish on is the open sourcing and verification of models. So when you're creating like a response from a GPT, you don't necessarily know that its response is a pure function of its inputs and the model that was stated. Well, if you open source this through blockchain, you can try to verify that it was a pure function of what you inputted. Because some of these models might be suggesting for you to vote for one political party rather than another without you knowing. And how can you make, like, you need to think, how can you make blockchain easier to interact with by using AI? So what can you build with these thoughts? One thing that is really degen and is being built on here was Shield GPT. And basically, what it is a treasury on near that just has a load of money, a load of meme coins, and it will buy and sell meme coins based upon how well you shill it a new meme coin. and this is controlled by an AI model. So you go to this model, you go to this smart contract, and you say, hey, I want you to buy more Black Dragon or more Nico, which are meme coins on there. And if you convince it well enough, the model, then it will buy more of those tokens. And if you scan that QR code, you'll see how like a smart contract actually uses GPT. Something else that would be cool to implement is like an AI indexer, and you can just generate an indexer by saying, hey, make me an indexer for this smart contract that does bets for this specific account and bid amount. And also another idea could be like I say, trying to interact with blockchain in a more user-friendly way. You can navigate that through natural language. So I can say, hey, show me the top 10 NFTs by price on there, or get it to complete a transaction for you, like to swap 10 USDC for some Bitcoin or for some Ethereum. And yeah, AI agents with a named accounts that can interact with blockchain's economy. So I saw that there was this game that had like agents that sort of live in this blockchain game, and they just go about transacting by themselves. This would be a really cool idea to implement in your game. And finally, an idea I had was, I'm a pretty bad developer, so I make mistakes all the time. But if I could have, you obviously have ChatGPT to search your code for errors, but it's not very well trained on NEAR or Ethereum specifically. If you could build a bot that checks for like NEAR specific errors, that would be like so helpful for so many people, and I would thank you personally. They're all my ideas. If you have any other ideas, I'd love to see them and love to see them implemented, and I would love to help you implement them. So where can you get support? We have our docs. The docs are pretty good. I've authored some of the pages on there. And come see us. We have a booth. We would love to help you, like I've said. And we're going to be here till like, I don't know, 10 p.m. or something. But when we're not here, we have a Telegram, we have colleagues all over the world, people in America, people in England, like myself, people in Asia. So people are willing and happy to help you if you have any questions, if you're hacking till like 4 a.m. in the morning. But please get some sleep, people. I think I'm done there, but if anyone has any questions, I'm happy to take some outside. And happy hacking. Let's get this bread. Thank you.